Welcome to my 13th presentation for the team of purchase and contracts. And today's topic is how to negotiate rates for the sheet metal or fabricated items like bonnets for vehicles. Overall, this is my 87th presentation considering all the YouTube presentations that I have made so far. This is the image of a bonnet, how it looks like, and shown is also a press. Now, I will take this as a practical illustration for sharing the costing approach. What I plan to include in the presentation are what are the key fabrication processes for sheet metal items, what influences the cost of fabricated items, approach to negotiating rates, who should negotiate the rates for such fabricated sheet metal items, how to estimate raw material cost, how to estimate and portion cost of plant and machinery for fabrication, how to compute tools cost, how to compute jigs and fixture cost, how to compute manufacturing variable cost, how to compute manpower costs, how to compute quality control cost, how to compute marketing variable cost, how to compute overheads and vendor margins, and overall how to compute total cost. In the end, I have also given a pit, approach on pitfalls and negotiation strategy for such a negotiation. Of course, there is a one additional slide for additional earnings from my blogs and vlogs. Now, what are the 14 key processes for fabrication and sheet metal items? These are now on this slide. I have given column 1 is for the processes and column 2 is purpose. Like column 1 is blanketing. Purpose is cut sheet metal coils into required size blanks for further processing. Process number 2 is press forming or stamping, which is for shaping the blank into desired 3D contours. For example, bonnet, door, outdoor skins, and removing excess materials. Third is trimming and piercing, remove excess materials and create slots, holes or cutouts, etc. etc. So this includes like MIG welding, spot welding, bending, sorry, then clinching, riveting, surface treatment, top coat, painting, sealant applications. So I'm not giving all the details which you can read at your layer. And of course, last one is the quality control aspects. Now this is the image of a final bonnet, how it looks like for a vehicle. Now what are the what influences the cost of fabricating sheet metal items? The technical aspects. First I'll take up technical aspects. These are they're shown in this table. Column 1 is technical aspects, column 2 is description. For example, the first aspect is type of the machines used: power, shear, cutter, hydraulic presses, power press, spot welding, etc. And depends on the machine age and condition, and downtime and frequency of the tool changes, etc. And the type of the machine, whether it is general purpose or CNC, etc. Then fabrication parameters like material forming rate, pressure and depth of the forming, tolerance and surface finish. Tools and specifications like shearing blades, punching dies, trim punches, spot welding electrodes, jigs and fixtures, shearing fixtures, press die holding fixtures, welding fixtures, painting fixtures, and jigs, etc. Change over times. Operator skill, very important. Skill levels which influence the cycle time for and the rework and the tool life and the supervision required. Then batch setup time per batch, longer setup increases the cost per piece, and repeatability and material type, material workability. I mean, this I am talking about the different kind of material which I'll take up like CR, HR sheets, etc. And specifications and their thickness and quality control and inspection requirements for the raw material, for the working process and the finish and the documentation thereof. Commercial aspects are usual like number of pieces or quantity, rates of the raw materials like HR sheet, CRC sheet, angles, plates, etc. Skill, labor availability and rates, competition, payment terms, customer specific requirements, traceability, packaging, labeling, and vendor relationship, etc. Approach. One practical illustration of a vehicle bonnet has been considered for ease of understanding the negotiation steps based on my hands-on practical experience of negotiations of such items during my tenure in the manufacturing industry. In this presentation, cost elements have been identified and summarized in the following slides. and for each major cost element, separate resource template has been developed, providing detailed methodology how to do that. These templates have been prepared and provided in separate PDF files, taking into account the challenge of incorporating them into PowerPoints, and they will be shared freely made available to you on request. However, the design of each resource template has been shared in this presentation, and the cost estimates as above are to be compared with the quotes received from the vendors, and negotiations are to be held on a logical basis. This practical illustration can be taken as a reference base for negotiating similar kind of sheet metal fabrication items. Who should negotiate? Very important question. A team of competent professionals with the necessary skills out of the 40 skills which I had shared must negotiate the rates and terms. The computation of the cost is demonstrated in the PDF, which can be requisitioned as a challenging to accommodate these in the slides. These blank templates which I'll be sharing in this presentation, you can instantly download and use this for negotiating the rates of such components like vehicle mudguard, bonnets, doors, roofs, area storage, and unit comprising of any unit comprising of sheet metal. How to estimate? Number one, cost elements. How to estimate raw materials cost for fabrication sheet metal items. Illustration: bonnet. Now let's assume that there are 25 bonnets to be negotiated per year. Then key raw materials are, as I shared, CRC sheet, HR sheet, etc. And size assumption is for a medium duty vehicle, and cutting wastage allowance assumed is 15% yield loss. Steel rate negotiation to be based on the prevailing rate of the steel coils and conversion charges applicable, and the type of raw material consumption estimates our assumptions are only for negotiation approach, and this can vary certainly. Now let me come to this. Now this is to be computed in a sheet which I have shared, having 8 columns: serial number, type and variety of the raw material, specification, size of the raw material like HR sheet, CRC sheet, etc., sheet thickness, net sheet required in terms of kgs, and gross total sheet requirement with considering say 15% scrap, it can be vary, and approximated per kg for the raw sheet, and the estimated cost per bonnet. Now this is computation is done in a resource template called RT1, RT1 resource template 1. The estimated cost in our illustration is rupees 1150 per bonnet, and this I will be sharing to you. I have attached a Google form which you can click and send to me, and the same working of this of 11 rupees 1150 will be emailed to you. And there are 8 more resource templates which I'll be sharing. It is considering the complexity of the calculations and size, it is difficult to accommodate this in the PPT format. How to estimate and portion the cost of plant and machinery illustrations. I am assuming here that these are the general purpose machines, not CNC, and annual production is 100 bonnets per day or 250 working days, 25,000 bonnets per year. Key plant and machinery assumed are power shear cutters, hydraulic press, power press, spot welding machines, trim press, etc., etc., and single 8-hour working shift, and machine utilization assuming 80% and machine life at 10 years. Scrap and downtime are excluded here, assuming that these are included in the raw material cost. Then the types of plant and machinery specification and cost of in our illustration which are there in this template, which will be called RT2, they are simply for understanding, and actual specification will certainly vary. Now cost assumption for each machine have been computed considering annual cost, which is equal to based on the depreciation plus financing cost plus annual maintenance cost for this plant and machinery. And once this total costs are worked out, for this will be divided by the 25,000 bonnets. Now this is the resource template which I am talking about. Resource template 2, it has got 10 columns: serial number, machine type, specification, size, production capacity, bonnets per shift, capacity, the value in lakhs, the depreciation amount, financial amount, charges, I mean annual maintenance charges per annum, the total annual cost, which is combination of column 6 plus 7 plus 8, and the total cost, and cost per piece dividing the total annual cost by 25,000. And in our illustration, this works out to be rupees 187.20 per bonnet. and I will be forwarding this once you requisition this. How to compute tools cost? Again, volume considered is 25,000 and key tool include here in our illustration shearing blade, punch and die set, trim punches, spot welding electrodes, paint spray gun, etc. And the type of tool specification, life estimates, etc. are just indicative for your understanding, and this will certainly vary. The life of tools is given in the bonnets per tool and not years, and resharpening cost is also amortized over the tool life, and cost per bonnets per machine are been taken. This is the template called resource template 3 for computing this tools cost, which has got 8 columns, which is serial number, tool type, size specification of the tool, tool life in bonnets, and tool cost total, and resharpening maintenance cost, total tool cost, and the cost per bonnet. It has been the work from the working you will understand that this has been taken as this has arrived at rupees 25 per bonnet in our illustration. So just to sum up, the raw material cost is taken as 1150 has come out worked out 1150. The uh, cost of the planter machine is 187 rupees 20 paisa, and the cost of tool is 25 rupees. I'll add many more costs. Jigs fixtures. Now again same assumption of the volume, and key jigs and fixture assume shearing fixture, press die, holding fixture, welding fixture, painting jig, trim fixture, etc. And the total types of jig and fixture, life estimate, specification, and cost are only illustrative and only for understanding. And maintenance costs include wear parts like bushes, pins, and clamps as per the minor realignments, and cost per bonnet is based on the initial cost plus maintenance cost divided by the life. Now, this is the template called resource template 4, which has got 8 columns. Again, one is jig and fixture type, name of that, specification, size, life in bonnets, and cost, and maintenance cost, and total cost, and total cost per bonnet. And this has been estimated as rupees 33 rupees 30 paisa in our illustration, and I will share this once you requisition this. Manufacturing variable cost. Again, assuming production of 25,000, the list of manufacturing variable costs include like cost of power, welding electrodes, hydraulic oil, lubricant, grease, paint, thinner, bushes, spray consumables, coolant, cleaning chemicals as per the specification captured in the template. And these costs, as I was sharing, are estimates only for your understanding. Now, this is a template shown which has got 6 columns. Column serial number 1 is column serial number, variable type, which is manufacturing variable, what is the name like power, etc. Then specification, then the consumption per bonnet, the unit rate, and the cost per bonnet. In our example, it works out to be rupees 445 per bonnet, which I have shown detailed computation in my PDF, which I will share on your request. How to compute manpower cost? Again, assuming that it is a non-CNC operation and 25 bonus per month, the rate assumed for skilled labor in the case of India is say assumed as 750 per day and unskilled labor as 500 per day. Of course, this skilled operator rate has been taken uniform for each type of the operator, machine operator, but it can vary. And the manpower activities they include handling and setup time for each of the plant machine listed earlier, non-continuous process, and machine downtime, reorientation, repositioning, welding complexity, etc., and painting by the guns, and inspection and touch-up time. The estimated cost, manpower cost per bonnet is worked out to be rupees 470, which is skilled cost is rupees 282 and unskilled is 188 per bonnet. And this is based on the template shown here, which has got 7 columns, serial number, operation or the machine, the skill type. I have in the skill type I will have 2 rows each. One is the skilled and the unskilled, and realistic minutes or per bonnet to be taken for each of the operation. Then man days per bonnet, based considering 8 hours per shift, that is column 5 is equal to column 4 realistic minutes divided by the 8 hours, and the skill cost, which is based on the rate of 750 rupees or 500 rupees depending on the skill and unskilled. And unskilled and cost, this cost is shown separately for skilled and unskilled. Okay, now I have also taken how to compute the list of the QC cost, and here is a tentative list of the type of gauges etc. to be used for measuring various parameters. The paint related aspects are not shown here, the gloss etc. Now, this assumption is that the vendor will be expected to look at the quality control cost for the raw materials and work in process and the final finished also. And gauge, as I was saying, includes vernier calipers, welding inspection gauge, paint thickness gauge, etc. And sampling rate, as assumed that it will be 10 to 20% depending on the process capability and criticality. And gauge life is assumed to be 5,000 to 20,000, which I have shared in my working PDF file for each type of the gauge. And there can be some outsourcing of the QC, like lab test, which are either occasional or high precision or expensive for tensile strength, destructive test, etc., etc., for the raw materials. This is the resource template having 10 columns: serial number, quality control, and test, item and type and variety, specification size, percentage sampling to be pursued, gauge life in terms of bonnets, gauge cost and maintenance cost for the gauge, the total cost and cost per bonnet has been computed. It works out to be, in our case, 16 rupees per bonnet by populating the template called resource template 7. Marketing variable cost. Again, same assumption. It is assumed that the finished bonnet will be shipped to us, and let's assume that the weight is 10 kg per steel with a surface area of 1.5 meter per square, because this to be sent by the trucks. And let's assume that batch size is 100 bonnets per lot, and distance from the plant is 150 kilometer for our assumption. And this will be sent by open truckload, standard LCV, light commercial vehicles. And the key marketing variable cost include primary packing, palletizing, securing, handling, loading, freight, marine transit insurance, traceability, code, punching, secondary packing. Now this also includes this loading, unloading, both at the vendor end and at the buyer end. So here is a template, which is simple template of 4 columns: serial number, cost head, assumption, and cost per bonnet. It, in our case, it works out to be rupees 105 per bonnet. See, considering the size and complexity and finish, this cost looks a bit high, but it is so. Overheads and vendor margin. Now, overhead assumption, it has been taken as 10%, though it can vary from 8 to 15% for a medium scale reasonably efficient setup. And list of the few overheads are like shared services and fixed facility expenses such as admin, office staff, rent, software, security, plant maintenance, utilities expenses like electricity, compressor, and so on. And overhead is based on 10%. The working amount I'll be showing in my last slide. And vendor margin assumption is at 12%. It can vary from 10 to 15%. And list of the few parameters, as you know, affecting the vendor margin are like vendor profile, competition, automation, location of the factory, and the type of technology chosen. Now, this is a final summary of the all the costs which I have shared in my previous slides. Like raw material costs, in the this is shown in this last column. This table has got 4 columns: serial number, cost element, computation, template number, and the cost element. Like raw materials, if you recall, it was 1150 rupees. Plant and machinery is R2 187.20. Tools is 25 rupees. Jigs fixture is 33.30. Manufacturing variable cost is 445. Manpower cost is 472. Quality control cost is 16. Marketing variable cost is 105. And the subtotal works out, which is the manufacturing cost, is 2433.50. And if you take overhead at the rate of 10% or row number 9, which is subtotal, it's 243.50. Then we compute the margin at the rate of 12%, which is based on the subtotal cost and the overheads, which works out to be 321.25 in the row number 11. And then subtotal of these two, that is row number 9, 10, 11, is works out 2998 rupees 25. And taxes at the rate of, say, assuming GST of 18% in India, so let's say it is, say, 539.75. So total cost works to be rupees 3538. So this template can be used in any country and for any type of currency, and similar approach can be followed. In our case, it works out to be 3538. Now, pitfalls and negotiation strategy. The negotiation, this has got three aspects, three columns. One is the aspect, the second is the pitfall, and the strategy or the tips for negotiation. First principle costing approach. The supplier treats fabrication cost as a black box, so you have to ask for the breakup of the inputs for each cost element, not merely the lump sum cost. Rate material raw material cost. Vendor may quote based on the raw material procurement from a dealer or retail market and consider high percentage of the cutting and wastage margins. So please insist on steel buying from primary producers versus traders or dealers, and always ask the supplier for the nesting layout of the blank and the blanking plan to validate the scrap allowances. Plant and machinery cost. Vendors may amortize the machine cost. This is a pitfall. Vendors may amortize the machine cost over fewer pieces and not share disclosures if the same press and equipment is used for multiple parts. Always the strategy or the tip is that always verify production capacity versus actual utilization, and if you amortize over larger production volumes, cost per pieces may drop significantly. Tool cost. The vendor may charge high tooling cost per part without any justification. So please confirm the tool life data with the sample runs or ask for the proof from the similar jobs. And for high value production, tool modernization justifies significant cost reduction. Request ownership. This is very important. Sometimes vendors they ask for the advance to be given for the tooling. So request for the ownership of the high cost custom tools like press dies, etc. if payable, if paying full price. Jigs and fixtures. Vendor may again demand here higher jig and fixture price. The strategy here is ask for photograph or tool room drawings and push for the shared amortization if the same fixture is being used for more than one variant, and if jigs fixtures are simple and manual, negotiate lower amortization cost. Manufacturing variable cost. These are vendor may ask arbitrary costs and always ask for the actual consumption, logbooks or monthly purchase data. This is challenging, but it has to be done. And then direct manpower cost. The vendor may ask for unrealistic manning ratios for skilled and unskilled ratios and overcharge rates versus the actual payouts. So please do factor in the man-hour rates based on the competition rates in the respective city where the vendor is located for the skilled manpower and unskilled power, and look at also the statutory rates which are prescribed by the government. Marketing variable costs. Vendor may follow inefficient supply route and plan lesser number of pieces per trip. Uh, so please negotiate the truck route planning and the number of pieces per trip and the mode for supplying this and shipping this. Better to negotiate C and F, cost and freight and rate with the vendor, and keeping insurance to our to the buyer, because that will help you negotiate to settle the insurance claims faster. Overhead allocation, ask for the basis of allocation, and vendor margin again benchmark with similar vendors and stress on open book costing. And taxes are there is no there is no it has to follow the statutory norms. There should be no compromise on this. So this is a overall summary which I have talked about, or the total cost. There are 9 resource templates which are there, which you can requisition and I will provide. And lastly, I just wish to say that you can also have additional learning from my various vlogs and blogs which have been posted on my YouTube and website. And for Udemy course, which is related to the negotiation, there are 12 articles which have been posted, and there are about 2 lakh views, 202,639 2 lakh views, and hours watched is 5,584 for a mere recording time of 12 lectures of about 3 hours. And so that means people are liking it, and clicks on the websites are 12,946. This is as of 19th May. Then there are 2 books which you are interested. I am not giving the details. So I have given the links for my YouTube and also website, and also the link in case you decide to buy the my course. Thank you very much and happy learning.